Hi everyone, I hope you're all doing well. My name is Rachel Wan and I'm the lead product manager for computational computing at IBM. Today I'm joined by my colleague Ram Pai, who is the lead architect for computational computing at IBM. In today's session, I would like to discuss how IBM Cloud has partnered with Agilent Systems and Intel to offer a computational computing solution aimed at digitally transforming a nationwide healthcare platform. We'll also explore how you can leverage computational computing in a variety of use cases beyond healthcare and how the solution can help you safeguard your data, enable your business, and drive innovation. This nationwide digital healthcare transformation is in need of a robust, secure, and user-friendly healthcare platform to securely store millions of electronic patient records. IBM, together with Agilent Systems and Intel, created a back-end hosting environment using dedicated servers to store these data. IBM deployed Red Hat OpenShift as a trusted platform for application scaling and Intel SGX for its proven success in computational computing use cases. By combining Intel Xeon processors and Intel SGX for data protection, organizations can securely operate workloads in any environment. Agilent Systems, in its Marble Run solution, enhanced IBM's healthcare platform's host environment with computational computing capabilities. Marble Run simplifies the orchestration, verification, and scaling of Intel SGX enclaves. Agilent Systems solutions ensure that data remains encrypted while enabling remote attestation, which allows for verifiable security down to the source code level. Remote attestation also confirms that each Intel SGX enclave has the latest security updates before revealing any data. Moreover, the healthcare platform features operation exclusion, which ensures that not even system administrators managing the backend services can access patient information. Another critical aspect is IBM's use of Marble Run for enclaves built with C++ and Gremlin, which are utilized in the healthcare platform document processing context, including PDF verification and transformation. The healthcare platform currently handles millions of users, effectively maximizing patient care software while safeguarding sensitive data and driving innovation. As the solution continues to evolve, additional capabilities have been added. IBM now offers SGX in a cloud environment as virtual servers for virtual private cloud. Furthermore, IBM offers computational computing with Intel TDX virtual servers for virtual private cloud, ensuring robust and secure environments for cloud applications and easy adoption. SGX and TDX virtual servers for virtual private cloud eliminates trust concerns when clients migrate their sensitive workloads to the cloud, allowing them to take full advantage of the benefits of cloud computing without compromising security. Computational computing is already driving innovation and security across multiple industries. For example, a large digital asset custody, transfer, and settlement platform leverages computational computing to secure digital assets. One of the key challenges in this space is protecting cryptographic secrets and managing access across large corporations. To address this, computational computing is used as a secure access mechanism for a digital vault. In the healthcare industry, a tech firm utilizes computational computing to improve encrypted data sharing and collaboration between insurers. Traditionally, organizations have been limited to using only internal data to solve problems, which restricts innovation and efficiency. Computational computing enables multiple parties to collaborate on shared data while ensuring sensitive information remains protected. In artificial intelligence, a medical device company employs computational computing to protect its AI algorithms and intellectual property. With the urgent need to safeguard the core intellectual property of AI models, computational computing provides runtime protection, ensuring the security and confidentiality of algorithms. These examples highlight how computational computing enhances security, fosters collaboration, and drives innovation across various industries. Looking ahead, we continue to advance its confidential computing offerings, expanding support for both IBM Z Linux 1 and x86 architectures. As part of our roadmap, with advancements in our confidential platform AI services, we will further empower businesses to scale securely. With a robust platform supporting both Z and x86, businesses can confidently scale secure computing solutions across hybrid cloud environments. Now, I'll hand it over to Ram for a deep dive into solution details.
Hello, I'm Ram. I'm the confidential computing architect at IBM. Earlier, Rachel talked about the healthcare platform and the services that it provides and the collaboration that has been done with IBM, Intel, and Agile systems to enable such a platform. The architecture that drives that platform is SGX bare metal servers from Intel. These are the servers which are initially configured with EPC memory, which is the memory that is used by SGX applications. When it is initially instantiated, it is configured with this EPC memory. When the machine is booted up, the first thing it does is it has to go and get itself registered with the Intel PCS service. Intel PCS service, as part of its registration, offers a PCK certificate, which is then can be downloaded by the cloud service provider into a PCCS caching service, a PCK caching service called as the PCCS. So that certificate is available, can be made available in the PCCS, and the owner of the platform can use or download that that PCK certificate from PCCS, or it can download it from PCS. Either way, doesn't matter. But the end result is the PCK certificate is needed. That PCK certificate is then used by the code generation service that is running on the platform, on the bare metal SGX server platform. That service offers codes to any applications, processes, pods, you name it, whatever is running on that server. The pods that are running on that server gets their code from the QGS service. The code is then used to get it to be verified through, and that is facilitated by a confidential service mesh. In this case, it is the Marble run from Agilus. So once that code is verified, secrets are released. In this case, SGX containers are deployed in the pods, and the whole cluster is running. That's the key here. The SGX containers are basically applications which are containerized, which can be natively containerized, or it can be containerized using ready-made tools like Grameen. And there are other tools as well, which are CCNF compliant containers, which can be deployed through standard orchestrators like Kubernetes or any of those things. So that's the idea here behind, and that's the architecture that drives the healthcare platform. Now going forward, we have the IBM Cloud now offers the SGX virtual servers. The workflow remains exactly the same, except that there are two steps that are not needed anymore. They can be just eliminated. The first step is where you go and register the platform with Intel PCS service. That is not needed. That is already done for you by the cloud service provider. And the ability or the requirement to go and get the PCK certificate from either PCCS or from PCS, that is also not required, because our cloud service, as part of instantiation of your SGX virtual servers, fetches the PCS certificate, keeps it ready, and injects the PCS certificate in the virtual server, in the SGX virtual server. So when your brand new SGX server is instantiated, right, the PCK certificate is readily available to you, and it will stay available to you throughout the lifetime of the SGX virtual server. So that certificate, you don't have to go and fetch it from anywhere. And once you get the certificate, the certificate is anywhere there. You use the certificate. That certificate is used by the code generation service that is running on the SGX virtual server. which, as mentioned earlier, is the one that provides the code. The applications that are running on that particular virtual server will be using this the QGS service to get the code and get it verified the standard way through some through facilitated by Marble Run, and the workflow is the same then onwards. But the key and the most important point that I want to stress upon is you don't have to go and register the platform, neither do you have to go and fetch the certificate. Those are readily made available to you. And that's the highlight of our SGX virtual service, which facilitates this workflow. And going forward, we will soon have TDX virtual servers available, and that will open up the door for the use cases that are facilitated by Constellation contrast from edgeless. Essentially, you have the whole Kubernetes cluster confidential, which is facilitated, enabled by Constellation. The pods are TDX pods, which are TDX virtual machines. These pods get their codes from the QGS service, which is running on the server, on the TDX bare metal server. It is transparent, hidden. The applications that are running on that server, in this case the TDX pods, get their codes either through a VSOC call or through a TDVM call. Either of them can be used and are supported. Get the code and use that code to get it verified. And Constellation, or in the case of Contrast, they both will facilitate verification of that code, and the whole use case gets enabled because of that. So this is something that is coming down the line, and that will enable more use cases and make confidential computing even more easier, lift and shift to most of the workloads and the use cases that they need them. Thank you.